So we've looked at working with A and then H and K to do some transformations. We were flipping the graph, stretching, compressing the graph, shifting it left, right, up, down. These can all be combined into what is called the vertex form of the quadratic equation. And so the vertex form of the quadratic equation, or of a quadratic function, sorry, is right here, A, H, and K. Again, remember, A is our stretch and compression, and then the flip up and down. H, opposite number, does the left, right. So negative numbers become positive numbers become negative. And then K, taking its actual value, shifts it up and down. Let's take a look at this one example here. We're going to describe the transformations relative to x squared. So what's going on here? So let's start with A. It's got a negative sign. What does the negative sign do? That makes the graph flip and open downwards. So this graph's going to open down. So we'll do this as a series of points. The 2 is greater than 1, so that's going to stretch it. Every point's going to go up twice as fast. Stretches by 2. There's our H, there's our K. So the H, positive 3 inside the brackets, means the H is actually negative 3. So it's going to go and shift 3 units to that. And remember, it's going to be a negative 3, so it's going to go to the left, to the negative side. And then the plus 7, that's going to go up 7. So we're going to also shift. So there is all the different transformations that applies. So you'd have a graph that opens down, you'd stretch it, shift it 3 to the left, and then 7 up. And so you could do these step by step when you apply them, or you could apply them all at once, depending on how comfortable you are when you're plotting these kind of things. So now we want to take a look at what's the vertex. Well, the vertex, recall, is the standard graph is 0, 0, but we've went 3 to the left, so that's to negative 3, and 7 up. So that makes the y positive 7. So negative 3, positive 7 would be the vertex. You can also just look here. Your h value is negative 3, your k value is 7. So we're calling that the vertex, and we sometimes use the v just to note that it's the vertex. Point is going to be hk. So since the vertex is hk, that means the vertex is negative 3, positive 7. Nice and easy. What's the axis of symmetry? So if you recall the axis of symmetry, that's that line that cuts the graph in half right through the vertex. Nice and easy to remember. It's just the x value of the vertex. The x value equals negative 3. There you have it, axis of symmetry. The next part here, we want to sketch the graph. So we've been doing, so depending on what you're asked, if you need to formally graph it and plot all the points, you can do that. Sometimes it's easier just to make a sketch of it for the different situations, just so we can kind of see what's going on really quickly. If you're asked to sketch it, you don't have to do anything super fancy. Just make a set of axes, x and y, and then sketch the graph, label the vertex and the and 2 other points. So what I do when I'm sketching is the shifts and then the up-down part is pretty easy. But the key thing here is that showing that stretch by 2. So I just overemphasize it if it stretches or compresses, kind of make it like exaggerated. So if I have a stretch graph, I'm going to make it fairly skinny. But in this case, we're opening downwards. So we're going to have something that's opening downwards, and it's stretched by 2, so it's going to be fairly narrow. But it's got to shift over 3 and then up 7. So I'll say somewhere like that. So this is going to be my vertex here. Okay, so I'm just roughly sketching this. It doesn't have to be exact. If I was graphing it, then yes, I need to be exact. And then I'm just going to, again, overemphasize that we're kind of stretching it out. So I'm going to make it fairly scrawny, fairly narrow. Okay, just over-exaggerate that a little bit. And then we're labeling the vertex that illustrates our shift. So our vertex here is -3, 7. And then we want to do 2 other points. And so how do we get 2 other points on this graph? Well, all you got to do is plug a value in for x. So pick some nice, easy x values, and you can plug those in. I'm just going to pick points on either side of 3. I'm going to pick -4 and -2. So all I'm going to do is do f at -4, and that equals 2 times -4 plus 3 squared plus 7. Solve that. -4 plus 3 is going to give me -1. -1 squared, that's just 1. 1 times -2 is -2. Plus 7 is going to give me 5. Done. And now here's the beauty of these graphs. Because I got that point, so -4, 1, I'm going to, or -4, 5, I'm just going to say it's right about here, -4, 5. These graphs are symmetrical about the vertex. So if I've gone over 1 point here and down to 5, if I go the opposite way, I go over 1 this way, then it's going to go down to 5 as well. So this point here is going to be -2 and 5. Just got 2 points. All I had to do was one calculation. So that's one way to do it. Save yourself some extra work and calculations. Just pick 1 point on one side of it and then pick the mirrored point on the opposite side of the vertex. And now I got 2 points labeled really quickly. So I got my vertex, my 2 points. Next part here wants us to state the domain and range. And so we look at that graph and we can use that to quickly state the domain and range. It's a parabola. That means these are going to continue on and on and on and on and on forever. And there's no real world restriction on this. So that means we can set the domain to be a set of x belonging to the real numbers. And then our range, well, goes as high as 7 and then everything below that. So our range is going to be y belongs to the real numbers such that y is less than or equal to 7. That's it. That's all. And so there's a way you can to look at taking all 3 transformations, A, H, and K, plugging them all in together, and getting a whole bunch of information from that.